Welcome to the right garage. Take 3.5. Transmission design 101. So we got 48 pitch, 32 pitch, or mod 8 because they mesh okay enough. Don't mix 48 pitch and mod 6 or whatever though. So I'm gonna go over Tinkercad, Fusion 360, AutoCAD Web for software for designing, and then services would be Send Cut Send, at home printing, or RC Addicts FDM services if he still offers that. How to design a transmission. First, you need to think about what you're putting it in. Is it a crawler? Go fast, blah, blah, blah. Go fast stuff, you can just stick a big spur or use a buggy diff or whatever and go from there. Crawlers, it gets a little bit more complicated because we're looking for gear reduction. So I got these, sneak peek, I got these 32 pitch gears here. Both are 45 tooth from the TRX4. And I also have the optional 39 tooth. So for this truck, we're going to run a 9 tooth pinion. Not this one. This one. Not this motor, but similar size. So 9 tooth pinion, 45 tooth spur, driving a 14 tooth pinion on a 39 tooth, or on the 39 tooth. So this pinion will actually be attached to this spur on one shaft, and this pinion will drive this final guy right here. So he will have a pin on the shaft, and he will have a pin on a shaft, and not the pinion, but just for demo purposes, because I don't know where my 14 tooth pinion went. Could go to a 13, change the ratio up more, but my drive ratio before the pinion and spur is about 14.6 because of the axles I'm going to use. Well, the front axle anyway. So, I don't know. Yeah, I can underdrive the rear. So, alright. I'm going to underdrive the rear in this case. I don't know if I don't know. They're Vanquish axles. I'm still new to them, so I don't know. Or I might go the 48 pitch route. But anyway, so enough getting sidetracked there. So you need to know your ratio. You need to pick your ratio. And a good all-around ratio, especially for wanting to run 3S or 4S or flopping back and forth between straight axle and portals, you want between 15, well, around 15 to 1, or a little bit higher. I wouldn't go any higher than I really wouldn't go any higher than 17 to 1 axles and transmission combined ratio. That's what this is right here. So this is my final with this ratio, with this setup here and the axle ratio. My final drive is 72.975. That's how many motor rotations it takes per 1 tire rotation. I don't know, some people think, oh, it doesn't matter. Well, you got different tire sizes. And just to show, this is just a 475, 47 Wild Peak. This was just some glue testing. So, say you're running 475s. Okay, that's great. That's what this runs. Well, that's what I'm running in my stance. Is Reds 475s. Huh? Say we go to, I don't know, 525 or 5.5. Well, your rollout just changed. And you might want to consider changing your gear ratio somewhere. And most of the time, the only place is at your spur and pinion. So, I mean, already this is kind of low for the taller tire, but I mean, it's 1800 kV 14 pole I'm running on 3S. I don't really plan on running 4S. So I should be okay with a 5.25 to 5.5 tall tire. I mean, it drives slow enough on 3S in my stock stance, and I'm okay with that. But, I mean, I'm going to leave the ability to change this out, because I got a trick up my sleeve. The transmission plates I've already done before are out in the garage. But anyway, those for this size of motor. Similar to the Deluxe Stumpy. I don't think I'm going to use these motors. These are 10 poles. And they're a bit notchy. So, when we measure our mesh, should be using the pinion. We'll just, let's see if I can zoom in here. Go away. We'll use 48 pitch for example. Yeah, I don't think I'm zooming in that far. Guess. Alright, so this guy is 10, say 8, so 4 and 5. K and K. Saving the day. K and K strip out of one of their hardware bags. You gotta do this on a flat surface. Doesn't wanna. We're going to try the one. Normally I can get... Man, it's just fighting me today. Alright, so... Don't use the K&K strip. I used to use them. So we got them tight all the way. Man. 26. We're going to call that 27 for good mesh. So you're going to add 0.4 to 0.5 millimeter for, I'm working with a 48 pitch here, 4 to 5 millimeter, 0.4 to 0.5 millimeters for 48 pitch gear mesh for your actual like total. And then you're gonna subtract, this is if you're working with pinions, but these guys it's a little bit easier because you can just put the pinion and then, you know, if you got a transfer punch or whatever, put a little paint on the end. Or I like to use mechanical pencils because you can make them as long as you need and they'll fit inside the hole. You draw your hole and then measure on the paper. But with these, and with what you got, so this 22 tooth and 45 tooth, the distance from outside to outside was 27. And then you're going to subtract half of this diameter and half of this diameter to get your center to center. So minus 9, that's 18. This is where it gets fun. Sorry, you guys didn't see that. This is where it gets fun. So the distance, like I said before, outside, plus 0.4 to 0.5 millimeters, minus half of your outer diameter here and here. So this one was, what did I say that was? 8. Yeah, this one's 8, that one's 10. So 4 and 5 millimeters, which is 9. So 27 minus 9, 18. That's our center to center for this perfect gear mesh in Tinkercad. And Tinkercad only. I don't know about Fusion 360, but Tinkercad only. You're going to have your cylinders, or your negatives as I call them, which is your clearance for the gear, both height and diameter. You're going to take that cylinder and you're going to copy and basically copy pasta, but you're going to take that cylinder that you've just created for your negative here, and you're going to copy it, and you're going to move it this distance over, and then place it there. Okay, that is your center to center mesh. But then you're going to take that cylinder that you just moved over here, you're not going to size this down. You're going to create another cylinder that you're going to basically, I guess, align and center with this one. Make sure you click on this cylinder before you start clicking the align buttons. Click on the cylinder first, then click the align buttons, and then delete this cylinder. And then that's your first gear cluster. I will actually 3D print those clusters to better explain myself. When you make those negatives and you get that done, if you want to get rid of those weird voids like this, you'll take a rectangle that is that is basically the radius length, but it's the actual diameter width. You're going to extend that out to, I don't know, you could just use this number because it's going to be centered. So you extend it out 18 this way, and then you'd make another one that you would just take this dot over here, drag it to 18 this way. So your cylinder's like this, and then you'll rotate. Then you'll have a block like this, and a block like this. You're gonna copy this, select this, rotate it the opposite way, the same amount. And then this will be left here. This will be gone. This won't exist. And then you'll have these two. So it kind of, I don't know, like connects to this void. Man, I really need to just do a live video of that. I guess this is just to show you how to measure for your mesh. We'll do the 32 pitch here. So 32 pitch, you can use a piece of paper and just make sure you run it in there. I guess he doesn't. Maybe a receipt. Dang, I'm wrong again. But these I'll just kind of just sit there because you can see the mesh better. I'll just leave a little air gap. On these, you gotta measure outside of the gear to outside of the gear. So if we're gonna mesh these two, their biggest part, $60, man. We'll say those are 61. 29.5. 25. 61. What was that? 14. .75. So this is the 39. This is the 45. Outer diameter. This is half of each one. Added a half of each one. So basically you're getting the, what is that, the average? Oh. Yeah. I just do it the other way. Nice. I haven't mathed in a while. Yep, that's right. So 61 minus 27.25. 0.75. 60. No. 5. No. Yeah. That's a... We borrowed the 1. 11 minus 7 is 5. Oh, 4. Duh. Let me double check this. No. That ain't right. Babe?
Yes?
What's 61 minus 27.25? I'm doing all kinds of wrong math in front of these people.
What was it again?
61 minus 27.25.
33.75. $61 minus 27.25.
Yeah.
Yeah, 33 and 3/4. 33.75.
Oh, so it's... I can do all this, but I can't subtract. Nice. So it's 33. It's 33.75 is center to center for this guy. Short description, you take the outer diameter of this or this and this, or this small and this bigger. You just need to get the average between those two outer diameters and subtract it from the actual outside to outside measurement. That gives you your center to center, which in turn gives you that perfect mesh. And in Tinkercad, if you want to rotate your gears, say you want to move your cluster, like this, you need to make sure you have the biggest outer diameter of the gear that you want to move on the opposite side, the direct opposite side, before you rotate. And when you rotate, only select those two voids or negatives, whatever you want to call it. Because when you rotate them, you will rotate them around the center of this. So this will never lose mesh with this guy. That's all I really got. So with my current project going on, this is kind of what I'm looking at here. That's the only time you'll see me measure in inches. Oh, my skid, yeah, 2.5 inch. This is 3.25. So the stock stance is about 3.25 wide. I want to shrink it down a bit, and I think I'm getting the 3/4 from. No, that's like a full inch. Oh, so much. No, it's 3. Can we get it down to 2? 2 might be too narrow. It's possible. Drive shaft to be tight. Guess it all depends, really. Go with the small guys, kind of like a Delix Fab Trans. Thing is, this isn't durable. I'd have to replace these and or the shafts probably every probably every 10 to 20 packs, maybe. I don't know. These are motor bushings, so they spin a lot faster, but they don't have side load like these do. These will want to separate this way. So I don't know how, really don't know how long they would last. Could always just do it this way and maybe send a couple out for testing. You know what, would you test this? No charge, other than getting back with me about it. Again? No, we're still rolling. What's going on here? Oh, battery. Well, that's it for Transmission Design 101. But, the AutoCAD web stuff, it's a lot easier. You design in 2D, and you get your thickness from how many ever plates you want to stack up, if you want to stack plates, or if not, just running posts like a Delix Fab Trans. That's where Suncut Sun comes into play, because they're super cheap as far as their pricing goes, but they have a minimum order. So like these will be available soon. It's just I call it the you name it trans, because I mean, with these you get different spur options, and then the transmission I'm designing will actually be able to switch between either gear, plus the option between 11 and 14 tooth. Like there'd be different inserts for the bearings to sit into. So there's that. Yeah, just keep in mind when you're designing a transmission, your biggest thing is your mesh, and obviously your orientation if you're doing multiple clusters. Hit that like, thumbs up, subscribe, hop over to Facebook and look for Right Garage. I'll be posting there as well. Mostly pictures of stuff I might be working on. Whatever. Thanks.